Section 16.2 One-way ANOVA. One-way ANOVA. ANOVA test. This is just another tool to help us run more testing for the hypotheses. Why do we call it ANOVA? ANOVA is abbreviation for the analysis of variation. So they took the first two letters, the first two letters. So that gives us ANOVA. Now in ANOVA, the reason we call it one way because we use usually one test here is used to help us with the testing. Is there two way? Yes, there's two ways and more, but we don't need that. And what is this used here for? So in the previous chapters, what we did, we ran into testing different hypotheses, and the ones we did like we tested two means of populations. We tested two means with known standard deviations, and then when the standard deviations for the populations were not known, we used the two samples t-test. We used the two sample t-test. Now the question is this: how about if we have more than more than two populations? How are we gonna do that? So like if you have population A, B, and C, you're gonna go like A and B together, A and C and B, C, a lot of work, and then there's more error in the what we call it, the level of significance, and getting to run through type 1 error and stuff like that. But we don't have to worry about that. That's why the one-way ANOVA is really a powerful way or tool for us to help us test the hypotheses. So to do so, we need to make sure that there are conditions that are met before we actually use the one-way ANOVA. What are the conditions? There are 4 of them. As you can see on the screen, the first thing, that the simple random samples, that the population or the samples taken from the population, they have to be simple random sampling. They are independent sampling that we're working with, and the distribution should be normal distribution for the populations where the samples are taken from, and also the equal standard deviations of the populations. So the population, they have, or they must have, equal standard deviations. So we, like 99% of the time, we assume this is these conditions are met. One condition, actually, the normality here, which I wrote down there about how to check for normality. One way to do so, we use the normal probability plots as we did in the previous sections, or we do make sure the population standard deviations are equal, but not required for the homework, but at least have an idea about what normality means. That these are just the conditions of before we are allowed to use this test. We're not going to run through the computational part as we did in the previous on chapter 14. Here they're just giving you an idea about how this works, but we're not going to again run through the population computational stuff here. So this is an example about 4 populations, and then from each population a sample was drawn, and then they computed each sample, the mean for each one of them, the mean for sample 1, mean for sample 2, and so on and so forth, and then they compare them and make a decision. So remember, this talks about the variance. In other words, it talks about the variation here, variation in the samples. Do we have enough variation or not? But in general, what we need to do, this test is actually a generalization for pool T procedural test for comparing more than 2 means, as I mentioned earlier. And one thing here to know is when we set up the hypotheses, if we have like three populations, that would be mu1 equal mu2 equal mu3 equals, if we have 4, you do equals mu4. So here I'm assuming n populations, so all the means are the same. And for the alternative hypothesis, H1 or H1A, at least one of them is different, or we can say not all the means are equal. So 2 different ways of presenting them. But if in case H0 is false, what does that mean? If the null hypothesis fails to work, then this means not all the means are the same. So if this is false, this is true. That's what this is saying. Just keep that in mind to help for the homework. Again, we're not going to run through the calculations. That's the one that takes a lot of time and not needed for the homework or the final exam, but you get an idea, quick idea what ANOVA test is for, the conditions for ANOVA test, why do we call it ANOVA, and then what is it used for? Is it used to test more than 2 population means? It could be 4, could be 5, there's no limit on that. And then the other thing is I will follow up with support this video with another video, not mine video, someone else's video from YouTube, to show you how the computational aspect of it are run, and which I recommend you watch that as well. That's what this section is about.